Hey everybody, Mr. Mack here. I'm going to go over some things here on the 5.1, 5.3 Mastery Study Guide here. There's a lot of vocab, and I'm going to go through it here, but I definitely recommend making note cards for this. And whatever it is that you need to do to learn and be able to remember later and use, the better you should do it. So let's jump right on here with altitude. So all of these are in reference to triangles. So if I have a triangle here, the altitude goes from the vertex to the opposite side, forming a 90-degree angle. This is an altitude. And so an altitude goes from a vertex to, so let's write it better here. It is, let's see, altitude, a segment with one endpoint at the vertex of a triangle and the other endpoint at the opposite base, forming a perpendicular, or I could say 90 degree also. Okay, there we go. And we make it blue. Okay, so that's altitude. Very good. Perpendicular bisector. So we've got like that. Okay, so let's make this, no, that's better. Okay, so perpendicular bisector, maybe I'll define this. Perpendicular bisector is a line that intersects a side of a triangle at the midpoint and forms a, let's say, 90-degree angle with the side. I say 90 degree this time because I don't want to use perpendicular in the definition. Okay. And so we're going to have to find the midpoint. Let's see here. I'm going to go on this side right here. So we're going to find the midpoint. So these two segments are congruent. And then we have a 90-degree that goes through. That angle is 90. Okay, that's a perpendicular bisector. Median. All right. Alright, so median is a segment with one endpoint at the vertex of a triangle and the other endpoint at the midpoint of the opposite base. Okay. One endpoint of a triangle and the other endpoint at the midpoint of the opposite base. There we go. Okay. So let's get merge, and we're going from, let's do this one, we're going to go from the vertex to the midpoint. So let's say this ends up being the midpoint, put some congruent symbols here, and that's our median. Okay, angle bisector. Okay, so angle bisector. A line that intersects a vertex such that it divides the angle in a triangle into two congruent angles. Let's see, a line that intersects a vertex such that it divides the angle, let's say divides the angle into two congruent angles. Okay. Nope. And maybe eggplant. Okay. You all have your own definitions written down. Feel free to use those. I'm just kind of going to this. Okay. And so we're going to go, let's go through this angle right here. Going through this angle, and we're going to cut this angle into two congruent angles. So that is our angle bisector. Now maybe I'll just make sure I take it, maybe go all the way through. Okay. So these are the four main types of segments and lines that find certain kinds of intersections in a triangle, and that's what we're looking at next. Okay, so define and make a sketch of the following concurrent points. So concurrent points are where more than three or more lines intersect. So let's just make some triangles here. Okay, nice pastels. Okay, so incenter is where the angle bisectors intersect. Where the angle bisectors intersect in a triangle. Incenter, angle bisectors. There it is. And let's do that. Okay. So angle bisectors, let's see. Let's get a different color here. We got, here's one. Here's another. Let's do doubles on these. Okay, and this right here is the incenter. And then, so, you know, this requires three arcs when we construct. 3 arcs for our construction. When we do this, the first one goes across one of the angles, and then from those intersections we do 2 more. I'll show you that in a little bit. Okay, that was incenter, orthocenter, the point where all of the altitudes intersect. Okay, orthocenter. Okay, so for this one we got to do altitudes. Okay, so altitude goes from the vertex to the opposite side, forming a 90. Vertex to the opposite side, forming a 90. Vertex to the opposite side, forming a 90. And this is the orthocenter. Right there. All the altitudes. Circumcenter, the point where all of the perpendicular bisectors, thank you autocorrect, intersect. Okay, so this one, if we have, I kind of made intentionally a obtuse here, triangle. Here's our midpoint here, and we're gonna 90 degree that goes through that, and then we're gonna have, let's say, a midpoint here, and we get perpendicular there, and we're gonna have one here, get triples, goes like that, and here is our circumcenter, and it's out here because our triangle is obtuse, meaning it has one angle greater than 90. If this angle were 90, this circumcenter move up and it would be at the midpoint of the longest side, which would be the hypotenuse. If this triangle is acute, this circumcenter would be inside the triangle. Centroid, it's the point in a triangle where all of the medians intersect. Okay, median is, let's get a color here. Do we like that? Maybe just red. Medians are segments that go from vertex to the midpoint of the opposite side. Okay, so let's see here. Let's get maybe yellow, lemon. I'm going to go from the vertex to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. Vertex to the midpoint. Right? So these right here, these opposite sides are midpoints. And then we're going from the vertex here. So here's the centroid right there. And we'll do more here about how we find these in a little bit later on. We use circumcenter and centroid. We construct perpendicular bisectors or use coordinate geometry to find the midpoint. And we'll see that. Okay, so define and sketch midsegment. Okay, so midsegment, again, we're talking triangles. Inscribed circle. Okay. Circumscribed circle. Oh man, okay. Okay, so midsegment, this is from 5.1. A segment in a triangle with endpoints at the midpoint of the sides of the triangle. Okay, segment in a triangle with endpoints at the midpoint, at the midpoints of the sides, at the midpoint of the sides, at the midpoint of the sides. I don't know. Midpoint. Okay. So there are some properties here that we want to talk about too. So I got, that's a midpoint. That's a midpoint. Let's say that that's the midpoint. And let me just do this one first. So we know that actually I'll do this one first. Okay, so we know that these midsegments are parallel to the base side. So these are going to be parallel. And they're also going to be half the base. So if these two right here together are going to be double this one would have to be a single hash. So two of these base sides make one mid-segment, or we can say the mid-segment is half the base. So we know that the mid-segment equals half the base side, and the mid-segment mid-segment is going to be parallel to that base side too. So we have three pairs here that we could discuss, right? So I got those, and I've got, I could do doubles here, and this is also going to be congruent, and then this one would be triple, right? And it makes a triangle inside the triangle, and these four triangles are going to be all congruent. Okay, inscribed circle. So we get an inscribed, it's the point, okay, inscribed circle, point in a triangle from which the largest circle can be drawn, and it is, okay, point in a triangle, let's say, but okay, this is true, but this is the point, and let's put this in parentheses, in center, because it happens at the in center. A point in center in a triangle from which the largest circle can be drawn. Okay, I like that. So the circle goes inside from the in center. Okay, so the in center happens where the angle bisectors are, right? So okay, these are all angle bisectors. Here's the in center right here, and we can make a circle there. I mean, I'm just, making the notes. I'm not actually doing the construction or anything, so. Circumscribed circle. Okay, so circum means around. So a point, and this is the circumcenter in a triangle from which a circle can be drawn around the triangle, which goes through all three vertices. Let's put it that way. Okay. Let's format this a little bit. Yep. All right, so this circle, I'm going to put down here. So we need to make perpendicular bisectors for this one, right? So Okay, so this is perpendicular. And we need to find another midpoint here. So you guys should know how to construct perpendicular bisectors. We've done a lot of these this year. As I told you we would in the beginning of the class. This is a big one. Okay, so here's our circumcenter right here, and then from here we draw a circle, and that circle is going to go. Now I kind of faked this. This is going to be harder for me to do it. So it's going to go. Oh boy. Come on, fix it for me. Aw. Sometimes it smooths out my curves. Come on, smooth it out. Okay, there it is. Okay, so that was, those are a lot of definitions here. And we have lots of good notes and things like that that you can go back and study and make your note cards. Yep, I think I'll stop the video here and then I'll do the next part here in a separate video.